Here's the proof for the quadratic formula by completing the square. And so the way I'm going to show you this is by using one trinomial with numbers and then one with just variables. So notice here we have 2x squared plus 9x plus 3 equals 0. And I'll be solving this one at the same time. In place of the 2, I have an a, so ax squared. In place of the 9, I have a b, so bx. In place of the 3, we have a c. So they're done exactly the same. It's the same work. It's just, instead of numbers, we're going to use just variables. So the first step is to always make this x squared term just a 1 for the coefficient. And so I'm going to divide this entire equation by 2. So every single number here, I'm dividing by 2. I do the same thing on this one. I need to get rid of this a term, so I'm going to divide by a. And so it's the same exact process as with numbers. It's just, instead of that number, it's just a variable. And so what's left over? Well, when I do the division, I just have an x squared, and then a plus 9 over 2x, and then plus 3 over 2 equals 0. On this side, I just have just the x squared now, and now it's a plus b over a x plus c over a equals 0, because a goes into 0 times. And then the next thing, so we'll go ahead and write down what we did here. We divided by a, and then I'll use the abbreviation for what we ended up doing for this side here. Here we divided by 2, here we divided by a. And so the next step is to move the c term over to the other side so we can complete the square. So I'm going to end up having to do an opposite operation. And so I'm going to minus the 3 over 2. So I'll minus the 3 over 2. Over here, I'm going to move this term here over to the other side so I can complete the square. So I'm subtracting that c over a. So subtracting the c over a from both sides. And so we can go ahead and rewrite what's left over. We've got this x squared plus 9 over 2x equals negative 3 over 2. On this side, we have x squared plus b over ax equals negative c over a. So what we ended up doing here is just moving the c term to the other side. So I subtracted, I minused the c over a. So I'll use the notation for the variable form, the algebraic form, for what I ended up doing. Over here I just subtracted the negative 3 halves. Next thing to do is to complete the square. So the way I do that is I take half this term. So I'm going to write down 9 over 2, and I'm going to multiply it by 1/2. And so when I do that, I end up with 9/4. But I need to figure out what it is that I'm adding to both sides. So I take that 9/4, because that's going to be the number that goes inside the parentheses, because it's 9/4 plus 9/4 equals 9/2. So I need to square that number, or multiply it by itself, to figure out what it is I'm having to add to both sides. So I'll just write down, I'm squaring that number for now. So right in here, I put plus 9/4 quantity squared. So that's what I'm adding to both sides. I'm adding that 9/4 quantity squared. And I'll actually go ahead and square the number down below. And so over on this side, I do the same thing. I figure out what it is that adds to make b over a. Well, just take that b over a and multiply it by 1/2. So I'm left with b over 2a. And then again, I know that's the number that's going to go inside the factored form when I factor that perfect square trinomial. But in order to figure out what it is you have to add to make that a perfect square, you need to multiply this b over a by b over a. So that's b over a, or b over 2a quantity being squared. So plus b over 2a in that quantity is being squared. That's what I'm having to add to both sides. So plus b over 2a quantity being squared. So from this point, we can go ahead and rewrite what we've got. So our new part is this, x squared plus 9/2 x plus now 81 over 16 is what I get when I square the 9 and square the 4. And this all equals, and on this side, I end up with a negative 3 over 2, and then plus this 81 over 16. So I'm going to go ahead and do some work here next, and I'll go ahead and write down what we've got left over here. X squared plus b over ax plus b squared over 4a squared. Careful on that because you got to square the 2 and the a there. This all equals negative c over a plus b squared over 4a squared. Well, the next, again, what we ended up doing here is we completed the square. So we'll just write down completed square is what we ended up doing there. Well, the next step is to combine some like terms here, and then we'll factor this as we go. So the factored form, again, is just whatever you get when you take half your b term. So it's x plus 9/4, and that quantity is being squared. And then over on this side, we'll equal. Now we'll go ahead and add these two fractions together. So maybe off to the side, I'll show you what I end up doing here. I end up multiplying this negative 3/2 by 8/8. And so over here, I'll just write down negative 24 over 16. This was an 8 here I'm multiplying by. And I'm adding 81 over 16. So when I go ahead and combine these two terms, I end up having to subtract those numbers because they're opposite in sign. And so when I do that, I end up with 57 over 16. So I got that 57 over 16 by just doing some subtraction. So I just combined terms is what I ended up doing on this side. Over here, again, I've got the factored form. The factored form goes this way. It's whatever you get for half your b term. So it's x plus b over 2a. See, b over 2a plus b over 2a makes just b over a. And so that's quantities being squared. On this side, I end up having to combine these two terms. So I need a 4 and an a squared. So I need to multiply by 4a over 4a. You see, then 4a times a makes 4a squared. So they have the same denominator. So off to the side, I'll just show you what I get. So 4a times negative c makes negative 4ac over 4a squared plus b squared over 4a squared. Now here's the hard part. And the reason it's hard is because we haven't combined or added rational expressions together yet. We do that later on in this course, and so that's why this seems really difficult. But we go over this to see where this quadratic formula comes from. So I go ahead and combine these terms. I'm going to just write this as, since I can't combine the b squared and the 4a squared, I just write it as b squared minus 4ac. And this is all over a 4a squared. So I couldn't combine the negative 4ac with the b squared, so I just wrote it as two separate terms, looking at the signs that are between them. So the next thing I need to do is take the square root of both sides. So I'm going to do that on this side as well. And so when I do that, what happens is I'm left with the x plus 9/4 equals plus or minus the square root of that 57 all over 4. So I wasn't able to take the square root of 57, so I just left it as a number underneath the radical sign, but it's over 4 because the square root of 16 is 4. Over on this side, I'm left with this x plus b over 2a. You see, all equals plus or minus the square root of that b squared minus 4ac all over 2a. 2a because the square root of 4 is 2. The square root of a squared is just a. So from that point, we've got one more step. And again, what I did on this side is I just took the square root. Of both sides. That was what I ended up doing, explaining it in some words there. And so from this point, now I need to move this 9/4 over. So I need to subtract 9/4 from both sides. So I'm going to subtract that 9/4 here, subtract that 9/4 here. And over here, I'm going to end up subtracting this b over 2a from both sides. So minus b over 2a. And the neat thing about this, from this point here, is when we go ahead and write that down, this next step, you'll notice that the denominators are the same. So I'm going to write now negative 9/4, because that's what it is, a minus 9/4, plus or minus the square root of 57 all over 4. Notice the denominators are already the same. That should be the case on your problems when you're using this, completing the square method to solve a problem like this. So x equals, and then I've got this negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Notice again the square roots, the denominators are exactly the same. So when I go ahead and combine these as 1, I'm left just with, there's no extra work to do. I don't need to change the denominators because they're already the same. I can just write this as with one denominator since they are the same. So negative 9 plus or minus the square root of 57 all over 4 would be my answer here. That would be it. So this would be the exact answer for factoring that trinomial. Over on this side, again, what I ended up doing is just combining or solving for x. Solve for x. On this side, we write down x equals negative b. See, again, the denominators are the same, so I'm just combining the numerators. Negative b plus or minus the square root of this b squared minus 4ac, and this is all over 2a. And this, the part that we just came up with, is the quadratic formula. And we're going to end up using this quadratic formula to solve problems. See, what we can do is just take our a term, our b term, and our c term, and we can plug them in to these variables, and that will give us our answer just like we have here. And so that's what we're going to practice in the next part.